The quotient rule. This video is about the quotient rule as a method of differentiation. Now, the quotient rule deals with expressions written in fraction form. Say y is u over v, or y is a function of f divided by g of x. If an expression is written in this format, we can use the quotient rule to get the derivative. And the quotient rule says that if y equals to u over v, the derivative, dy dx, is going to be v times the derivative of u minus u times the derivative of v divided by v squared. This is the quotient rule. Let us look at an example here. Given that y equals to x over 2x plus 1, we want to find the derivative, dy dx. So that means, if you can see here from our formula of the quotient rule, all we need to identify is the u and the v. You can see here from our function here that our u is going to be x and the v is going to be 2x plus 1. Now we can go ahead and find the u, the x as equal to 1, and the v, the x as equal to 2. So now it's time for us to put in our expression here in our formula. So the derivative dy dx, when you're following the formula, we have to get the v, which is 2x plus 1, times the derivative of u, which is equal to 1, subtract u, which is the x, multiplied by the derivative of v, which is 2, all of it over v squared, all of it over 2x plus 1 squared. So our dy dx here is going to be, this is when we can open the brackets here, so we have 2x plus 1 minus 2x, all of it over 2x plus 1 squared. You can see now the answer is going to be 1 over 2x plus 1 squared. This is the quotient rule. Let us take a look at another example. Y equals to 3x over root of x plus 1. You can see here our u is equal to 3x and our v is square root of x plus 1, which we can write as v equals to x plus 1 to the power over half in order to make our differentiation easy. So we have the dy dx here as equal to 3, and then you have the dv dx here as equal to a half into x plus 1 to the power of negative a half. So join the equation together. Remember that we said if y equals to u over v, the derivative here is going to be the derivative of u times v minus the derivative of v times u over v squared. This is the quotient rule, is what we want to apply here. So we come here and say, now our derivative here, dy dx, we are following the formula. We have the derivative of u, which is equal to 3 times v, which is x plus 1 to the power over half, minus the derivative of v, which is a half x plus 1 to the power of negative a half, multiplied by u, which is 3x, all of this divided by v squared. So it is x plus 1 to the power of a half, all of it squared. So now it's time to simplify the expression here. At this point, it's about factorization, but basically you have your derivative here. You have applied your rules. You have applied the quotient rule, so you have your derivative. What left here is to try to simplify it, try to factorize it. So factorizing this expression, we have dy dx here. I'll put a 3 outside, and then x plus 1 the power of negative a half also go outside. Then what's left here, since I put negative a half outside, here I'll stay with 1, so it is x plus this power of 1 subtracted by a half. I'll put it out later, and then here I'll stay with only x. That makes sense. And then over this one squared here, it's simplified to x plus 1. We can continue with the simplification. This negative a half, it is better when it is out, when it is down. So I have it down here, x plus 1 to the power of a half, and then I have x plus 1. And then up here, I open the brackets here, so I have x plus 1 minus a half of x. So when you go here, you have 3 outside here, but the derivative, the differentiation process is already over. Now this is just algebra, simplifying the expression, but the derivative process ended here. That's where the quotient rule ended. So this other thing here, we are just trying to simplify the expression other than having the answer in this format here. So here what we have, so here I have x minus a half of x, so I have x over 2 plus 1 over x plus 1 a half, and then x plus 1. So this one up here, you can simplify it. Guys, if you are good in algebra, it's very easy to simplify this expression here. So I can have 3 into x plus 2 over 2 into this one here. I can join it, and I have x plus 1 to the power of 3 over 2. Let us look at another example here. We have f of x equals to e of x cos of x. So in this case, what we have here as our u is equal to e of x. And what's our v? Our v is cos of x. So we have the derivative u prime as e of x, and the derivative v prime here as equal to negative sine of x. Now, our derivative here from our formula, you guys remember the formula here, it is y equals to u over v. So the derivative here is going to be the derivative of u times v minus the derivative of v times u over v squared. We are going to apply this, the quotient rule. All right, that means our derivative is the derivative of u, which is e of x, times v, which is equal to cos of x. Subtract the derivative of v multiplied by u. All of this divided by v squared, which is going to be cos squared of x. So you have applied your quotient rule. Now what's left is just factorization, but the quotient rule is already applied. This is your derivative, but you cannot leave the derivative like this. We need to factorize it. So what you have here, if you can factorize what is common out here, so we shall have ax into what you have here is cos of x plus sine of x, all of it over cos squared of x. At this level, we can leave our expression like this. This is our derivative using the quotient rule. So you can see all you need to do is to identify the u. In this case, it's x squared plus 1. And then you identify the v. In this case, is sine of 4x. The derivative here, the u dx, which is 2x. And the derivative here, dv dx, which is equal to 4 cos of 4x. We're using the chain rule here quickly, mentally. You can check out the videos on chain rule. Then we have the dy dx here as equal to, we are following the formula here, the derivative of u, which is 2x, multiply times v, which is equal to sine of 4x, minus the derivative of v, 4 cos of 4x. This one here multiplied by u, which is x squared plus 1, all of it over the v squared sine of 4x squared. And then we can simplify this. So this is your derivative, but we don't want to leave it like this. If there's something we can simplify, we shall do that. But at this level here, we don't need to simplify this. There's nothing that is much common here. So we can just leave it the way it is. So we just have 2x here sine of 4x minus 4 into x squared plus 1 cos of 4x, all of it over sine squared of 4.